Alrighty, so our last section, part three, non-electrolytes versus electrolytes. Usually when we talk about electrolytes, when you hear that word, you think of Gatorade and Powerade. However, electrolytes are actually important in terms of the body. So you notice that the electrolytes you get in Gatorade and all that, sodium, potassium, those particular ones, for example, are necessary for your body to function normally. So, how to tell something is a non-electrolyte? It has to be molecular, or you want to say has to be covalent, with some exceptions, of course. So if something is molecular, it is a non-electrolyte. It does not conduct electricity, hence the word. So if the word ends in "ose," so it's a sugar, or if it ends in "ol," it's an alcohol, that means that those things are going to be most likely non-electrolytes. They mostly consist of carbons, hydrogens, and oxygens. And one way to also look at it is that most likely it's going to be covalent. Okay, so that's between two nonmetals or between nonmetals. So hopefully you remember that from our previous. If the solute is ionic or polyatomic, sodium chloride, potassium nitrate, etc., those things are considered electrolytes. They conduct electricity, hence the name. In fact, sodium and potassium are necessary to conduct action potentials, which means that's how your nerves function normally. So what happens is that if you have, say, this cup of water, H2O, and you dump in sodium chloride, sodium will associate with the negative dipole. The chlorine will interact with the positive dipole in the water. That's what happens when you put things in solution. So electrolytes are ionic, so between metal and nonmetal. Also polyatomic, you want to include that as well. And most acids and bases. So hydrochloric acid, hydrobromic acid, sulfuric acid, lithium hydroxide, potassium hydroxide, potassium chloride, silver nitrate. Even though this has a lot of hydrogens and carbons and oxygens, so this has a lot of nitrogens and oxygens as well, this is carbonic acid. Therefore, it's an electrolyte. Ammonia is a base, NH3, even though it has a lot of um, nonmetals, it's still considered a base, therefore it's an electrolyte. Alrighty, so this brings us to the end of lecture. Your assignment will be uploaded to Google Classroom, and it will be due on March 26th, Thursday, by noon. Okay, you can type directly into the Google Doc and make sure you turn it in on time. Thank you.